Hey guys, today we're going to go over molecular names and formulas. You'll need to pull out these three things, and then let's get started. So, molecular names and formulas. Molecular just refers to molecules. You've probably heard water be called a water molecule before. We're going to learn how to name stuff like water in these slides below. Okay, so the past couple days we have gone over naming salts, which when we work with salts, we're dealing with a metal and a nonmetal, and when they exchange electrons, one of them steals, the other one gives away, they become cations and anions, and that attraction that happens between those two, we like to call an ionic bond. And so that's what we're used to. Today we are going to, though, be dealing with molecules, and molecules are a little bit different. They don't form ionic bonds at all. They only form covalent bonds. So as you're writing down these notes, one thing that might be useful that I did for my classes is we kind of did a really simple example of the differences between simple salts or salts and molecules. So simple salts, they only had ionic bonds because they were only dealing with cations and anions. Once we introduced complex salts, which the only difference here between simple salts is that we still get ionic bonds, but because we also have polyatomic ions now in play, we see that there are covalent bonds within the polyatomics. So ionic bonds is still happening between the positive and negatively charged things. Covalent bonds are happening within the polyatomic, but we still saw that we had ionic bonds still in there. Now what we're going to see with molecules is we no longer have ionic bonds, we just have covalent bonds. Now take a second and think about it. What types of things or atoms like to form covalent bonds? Let's remember real quick. Oh, it already showed back here. Let's go back, just so it doesn't show it already. So covalently bonded molecules, these things are between what types of atoms? Is it a metal with a metal with a nonmetal, or a nonmetal with a nonmetal? Okay, covalent bonds share. That means both of them want electrons. We're going to see that it's two nonmetals. And please remember that hydrogen also likes to do covalent bonds. So we're going to see when hydrogen bonds with another nonmetal, we still call that a molecule. Okay, cool. So rules for molecules. The biggest thing for this has to do with prefixes. Now, prefixes, hopefully you learned in your English classes what that means. An example that I like to think of that describes prefixes is hyperthermia and hypothermia. Those hyper and hypo in front of the thermia, those are describing parts of the word. Hypothermia means you're getting too cold. Hyperthermia means you're getting too hot. So these prefixes are also something that we use when we describe how many atoms are in each of these molecules. You will need to memorize the first 10 prefixes, which are these right here. Mono, which means one. Some of you may have gotten mono before. Di represents that there's two atoms within that element. Tri, you can think of triangle for three, so you've been familiar with that prefix before. Tetra, we've seen tetra in the class when we discussed shapes. We said tetrahedral was, for example, 4 different hydrogens coming off of a central atom. And we did methane, for example, CH4. And so that was actually tetrahedral shaped. Tetra meaning 4, there was 4 things coming off of it. Now penta and hexa and hepta, you can kind of just think of polygons. So pentagon, the pentagon, hexagon, 6 sides, heptagon, 7 sides. Octa will be a little bit easier for us to remember because octopus has 8 legs. Octa means 8. Nana looks a lot like 9 to me because if you replace the O with an I and the A with an E, it spells out 9. So Nana is 9. And then deca. Deca we see in the word decade. So 10 years, deca means 10. So with that, I need you to memorize these. If you remember some of those simple tricks or things that remind you of them, it's going to be a lot easier to remember these. Now, another thing about this is when we are naming stuff, and let me get out of this again real quick. When we're writing these things out, we will, list the elements, and we'll have to look at whatever the subscript is to find out the prefix. So right here, we don't have a prefix on carbon, so we only have one carbon. And then for the oxygen, we have two of them because we have that subscript there. So we have two oxygens. Now we have to find the prefixes for these. So one is mono, two is di. So we would say monocarbon dioxide. However, you guys have heard of CO2 before, and you normally only call it carbon dioxide. This is correct because of a rule that they have. If you only have one of the first element, and see we only have one, you do not need the prefix mono in front of it. So if just one, just say carbon. You guys have also heard of probably carbon monoxide before. That is CO. You'll notice that carbon still does not have the prefix in front of it. However, there's only one oxygen now, and so now we put the monoxide. So that's just a good example of that rule where there's only one of the first atom, the prefix mono is not used. Then a last rule, and you've seen this before, the second atom ends in I, just like in salts. So make sure that when you say it, it's not carbon monoxygen or carbon dioxygen, it's carbon monoxide. Okay, cool. So with that, that's pretty much all there is to this this lesson. I have a couple of examples we can work on. So take a minute, pause the video, try to do some of these, remembering that you need to list out the atoms, what the elements are, either the names or the formulas. Then you need to look for prefixes. And once you find those prefixes, you're going to want to write them in front and then drop the ending and add "-ide". So take a minute and pause it. I'm going to work through these in just a moment. Okay, so hopefully you have those written down. I'm going to make this full screen just because it does show the answers on the slides if you're not in presentation mode. So let's do a couple of these. SF6 was the first example. We want to write the name of this. So find S on the periodic table, and the name is going to be sulfur. Then you have F, and F stands for fluorine. We need to drop the ending and add "-ide" though, so we're going to say fluoride. And now we're not quite done yet, because this looks like we just have sulfur fluoride bonded together. We need to know how many fluorines and how many sulfurs we use to do this. So look at the formula. Sulfur doesn't have a subscript next to it, meaning that there's only one of them. Since there's only one and it's the first atom, we don't need to include mono. So sulfur is actually done. Now fluorine, on the other hand, has this 6, which means that we need the prefix hexa on there. So you're going to put hexa right in front of fluorine, and you're going to get sulfur hexafluoride. That actually is the answer right there. Okay, let's do another one. I think, let me make sure I'm doing this right. Okay, N2O. Okay, so find N for me. N is nitrogen. Now, take a second. I want you to decide which one you think is right. Do we say nitrogen or do we say nitride? Okay. Remember, the second atom only ends in "-ide, not the first one, so we're going to cross this out because we don't need it. We would say nitrogen. Now, how many nitrogens are there? There's 2, so we need to put di in front of this. Okay, O is oxygen. How many do we have? Just one of them, so we're going to put monoxide. And here's a good point that we should probably pull up at this moment. The prefix for one of them is mono, and then the word for oxygen is oxide. So if you really put it together, you would say mono, and then you put another O for oxide. This is purely optional. This is your preference. You can either put both of the O's and say monooxide, or you can just put one of the O's. I like to just put one, but if it helps you to remember the prefixes, I would just keep both of them in here. Same with if we were doing another example that ended with another vowel, for example, tetra. You could say tetraoxide, or you could say tetroxide. It really doesn't matter. You can communicate the same thing either way. Cool. So I'm going to erase these because they're not a problem. This is the right answer. Now, I have about 5 more minutes on this video, so we're going to have to go a little bit faster. N is nitrogen. We already said it's nitrogen, not nitride. It doesn't have a prefix in front, so it only has one, meaning we don't need to have any sort of prefix in front of it. So now this is done. Oxygen, there's 2 of them, so you're going to say dioxide. And that is the right answer right there. Cool. Okay, let's do another one. Looks like our problems are, next one is dichlorine octaoxide. So dichlorine octaoxide. You guys have probably already solved this as I'm writing this out. But let's do it anyways. The element in this is chlorine. Chlorine on the periodic table is Cl. And how many are there? Well, you have the prefix di, which means there's 2 of them, so I'm going to put a 2 right there. Now we have the element in here, some oxide. And oxide's not on the periodic table. Remember, that means oxygen. So we're going to put an O right here. And then how many do we have? Octa means 8, so we have 8. And that is our answer right there. Now one more. See if I have enough room for this. Dinitrogen tetroxide. Okay. Let's just make a new slide. Dinitrogen tetroxide. Okay. Find the element in here. It looks like it's nitrogen. Nitrogen is N. Di means that there's 2 of them, so put a 2 right there. Then oxide stands for oxygen, so we're going to put O. And how many are those? There's 4, so we're going to put 4 right there. And then that is our answer. Now you'll probably notice that there's kind of a trend going on. This is probably is the easier of the naming rules for students to learn, just because it's fairly simple and you just add a bunch of prefixes. I want to outline a couple of things for you. Notice we dealt with 3 different examples. Let me go back to this actually. We dealt with 3 different examples that dealt with nitrogen and oxygen just in different ratios. And so notice that when we have different ratios of things, 2 N's, 1 O, 1 N, 2 O's, 2 N's, 4 O's, all of these different combinations give us different names, which stand for different elements that have different properties. And so it's really important when we do these that we include all of the subscripts and that we don't reduce them. So for example, dinitrogen tetroxide, you would never reduce the subscripts to say NO2. That would make it look like nitrogen dioxide. These 2 things are completely different. We can't reduce the subscripts because that would change the name. So yes, please notice we don't reduce the subscripts. Now, other than that, I think that is everything I have for you. Yeah, I think that's it. There is some homework assigned to this tonight. I would look on Canvas to find that. And remember, we have our test coming up soon, and you can find some more details for that on Canvas. Thanks, guys.